Great civilizations have vanished without a single invading army. The silent, invisible force that erased them was a changing climate. These sudden climate shifts of the past are the hidden architects of history, toppling empires and scattering entire populations long before our written stories began. By the end of this journey, you will understand how these ancient upheavals hold urgent lessons for our own future. We will explore why the mighty Akkadian Empire turned to dust and what caused the Maya to abandon their magnificent cities. What do you believe is the greatest threat to a thriving society? 12,000 years ago, the world was a different planet. The last great ice sheets still clung to the continents, and humanity lived in a nomadic rhythm with the cold. Then the climate began to change, but this was not the slow, predictable warming we might imagine. The transition from the Pleistocene Ice Age to our current Holocene epoch was a story of violent instability, a series of climatic convulsions that would force our ancestors into a new way of life. This period holds the first great lesson in our story. Sometimes the greatest leaps forward are born not from comfort, but from crisis. The most dramatic of these convulsions is known as the Younger Dryas. For over 1,000 years, just as the world seemed to be warming, temperatures across the northern hemisphere plummeted back to near glacial conditions in a matter of decades. Ice core data from Greenland reveals a staggering truth. Average temperatures in some regions dropped by as much as 10 degrees Celsius, a change that would feel like moving from the climate of Paris to that of northern Siberia within a single human lifetime. Landscapes that were greening turned back to tundra. Animal herds shifted or disappeared. For the small bands of hunter-gatherers living through it, the world they knew was becoming profoundly unreliable. It was within this pressure cooker of environmental stress, particularly in a region we now call the Fertile Crescent, that something revolutionary took root. The old ways of following migratory game became riskier. In response, communities began to focus more intently on the reliable resources around them: wild grasses like wheat and barley, and animals like goats and sheep. This was not a sudden decision, but a gradual shift born of necessity. By selectively harvesting and later sowing the seeds of the hardiest plants, and by managing herds instead of just hunting them, they were inventing agriculture. This shift from foraging to farming is arguably the most important transition in human history. It allowed for permanent settlements, food surpluses, specialization of labor, and ultimately, the birth of cities and states. So, did climate chaos invent civilization? It is more accurate to say it provided the harsh, unforgiving exam for which agriculture was the ingenious answer. The volatility of the Younger Dryas did not make civilization inevitable, but it created the conditions that made a sedentary, farming-based life not just attractive, but essential for survival in many regions. This foundational moment establishes a pattern we will see echo through the millennia. A sudden climate shift acts not merely as a backdrop, but as an active, disruptive force that bends the arc of human history. It compels adaptation, and the form that adaptation takes can redefine what is possible for our species. The stage was now set. The experiment of settled society had begun, but as we will see, the climate was far from finished testing its creations. The experiment of settled society would face its first great test in the cradle of civilization itself. In the fertile lands between the Tigris and Euphrates rivers, a powerful new idea had taken hold: empire. The Akkadian Empire, founded by Sargon the Great around 2300 BC, was the world's first. It unified the rival city-states of Sumer under a single administration, its influence stretching from the Persian Gulf to the Mediterranean Sea. This was humanity's first attempt at organizing such a vast and diverse territory under a central rule, a monumental achievement in social complexity. Yet, within just a few generations, this colossus would fracture and fade, its cities abandoned to the wind. For centuries, historians pointed to the familiar suspects: invasion, internal rebellion, or administrative failure. But the soil itself held a different, more profound story. At an ancient site called Tel Leilan in modern-day Syria, archaeologists made a startling discovery. Digging through the layers of history, they found a clear line in the earth. Below it, evidence of a thriving Akkadian provincial city. Above it, a sterile, uniform layer of fine, wind-blown silt nearly a meter thick, a deposit completely devoid of the pottery, tools, and ashes of human life. This was not the result of a single violent event. This was a geological tombstone marking an abandonment that lasted for about 300 years. This dust, quite literally, was the writing on the wall. Analysis of this sediment pointed to its origin, not a local event, but material carried from vast distances by relentless, arid winds. The climate record, pieced together from ocean sediments and cave formations, confirms a catastrophic period of aridity that gripped the region around 2200 BCE. It appears a shift in North Atlantic circulation patterns redirected vital monsoon rains away from Mesopotamia, triggering a mega drought that may have lasted for centuries. The empire was not invaded by armies, but by a creeping, suffocating emptiness. Contemporary cuneiform tablets give this disaster a human voice. They speak poetically, yet desperately, of agricultural collapse. One lament reads, "For the first time since cities were built and founded, the great agricultural tracts produced no grain, the inundated tracts produced no fish, the irrigated orchards produced neither syrup nor wine, the gathered clouds did not rain." The lifeblood of Mesopotamia was its irrigation, a network of canals that fed its fields. In a prolonged drought, this very system could turn against the people. Without sufficient river flow to flush salts from the soil, and with increased evaporation under the blazing sun, the fertile land became poisoned by salinity. Crops failed, harvests dwindled, and the food surplus that fed the empire's soldiers, bureaucrats, and priests simply vanished. This raises a haunting, unresolved question. Did the very centralization that made the Akkadian Empire strong also make it uniquely fragile? A vast, top-down system is brilliant at distributing abundance, but it can struggle terribly with scarcity. When the rains failed from the Mediterranean to the Persian Gulf, there was no other fertile province to call upon for aid. The social contract, based on the king's divine ability to ensure prosperity, shattered. If the gods of rain and fertility had abandoned their people, then the ruler's legitimacy evaporated with the water. Communities likely turned inward, fighting over dwindling resources, and the great imperial project dissolved back into isolated, struggling city-states. The Akkadian collapse is more than an ancient tragedy. It is a stark, early lesson in systemic vulnerability. It shows us that a civilization's greatest strength, its complexity and integration, can become its greatest weakness when the environmental foundation it is built upon suddenly shifts. The empire did not simply fall. It was slowly, inexorably buried in dust. Centuries later and a world away, another civilization would face a similar, silent enemy. Deep in the rainforests of Central America, by the 6th century of the Common Era, the vibrant pulse of Maya life began to falter. The constant hum of activity in great city-states like Tikal and Palenque, places where towering temples were carved with the stories of kings and gods, grew quiet. The ambitious carving of stone monuments, a practice central to their culture and politics, largely ceased for over a century. This period is known as the Maya Hiatus, a mysterious pause in their historical record that speaks not of a sudden end, but of a profound and deepening struggle. The howler monkeys still called from the canopy, but the human roar of civilization was dimming. What could cause such a sophisticated society to step back from its own grandeur? The answer, once again, appears written not in stone but in water, or rather the lack of it. Far from the jungle ruins, in the cool, perpetual darkness of local caves, scientists like Douglas Kennett have found a remarkable climate archive. Stalagmites, those stone pillars growing up from cave floors, form layer by layer from mineral-rich water dripping from the ceiling. The chemistry of each layer is a precise record of the rainfall above at the time it formed. By analyzing these natural time capsules, researchers have identified periods of drastically reduced rainfall coinciding exactly with the hiatus. The Maya world was struck by a series of severe, multi-year droughts where the life-giving summer rains simply failed to arrive. This presents a compelling paradox. The Maya were not passive victims of their environment. They were brilliant hydrological engineers. In a landscape with no major rivers, they mastered water management. They constructed vast, plaster-lined reservoirs to capture rainwater, intricate canal systems to direct it, and maintained carefully managed agricultural fields. Their cities were designed as water catchment landscapes. So why did these adaptations fail? The answer lies in a terrible convergence. Their systems were engineered for normal climate variability, but the droughts of the hiatus were different. They were more intense and more prolonged, pushing beyond the design limits of even the most advanced infrastructure. When reservoirs dried up and the water table fell, the foundation of their society cracked. The climate shock did not act alone. It amplified every existing pressure within Maya society. To understand the collapse, we must look at the interplay between the changing sky and the troubled ground. Decades of growth had likely led to populations stretching the capacity of the land, even in good years. The political landscape was one of fierce competition between rival city-states, with warfare often tied to the control of resources and prestige. When the droughts hit, this tense system reached a breaking point. The failure of crops meant hunger, which eroded the authority of the ruling elite who derived their power from a promise of prosperity and divine connection. Competition for the remaining water and fertile land would have intensified conflicts, diverting energy and resources away from community survival and toward defense. The societal machine, stressed by overpopulation and political rivalry, seized up when the primary fuel, water, was cut off. The unresolved impact of this trauma echoes in the centuries that followed. The Maya did not disappear, but their world was irrevocably reshaped. After the hiatus, some cities recovered, but the political and spiritual center of gravity had shifted. The cultural memory of that desperate time when the gods seemed to withhold the rains must have been profound. It likely led to deep changes in their spirituality, perhaps a move toward rituals that more desperately sought to appease the forces of nature, and in their political structures, which may have become less centralized, less focused on the glory of single, godlike kings, and more on resilient local governance. Their story is a sobering lesson in limits. It illustrates that no matter how ingenious our adaptations, no civilization is an island. We are embedded within a natural system, and when that system shifts beyond a critical threshold, even the greatest engineering and the most powerful kings can be brought to silence. The silence that fell over Mesopotamia was not an isolated tragedy. Around 2,200 years before the Common Era, a wave of climatic stress rippled across the ancient world, touching civilizations that had no knowledge of each other's existence. From the banks of the Nile to the floodplains of the Indus, societies felt a profound and simultaneous shift. Geologists have given this global phenomenon a name, the 4.2 Kiloyear event, marking it as a turning point in Earth's own story. This was not a local drought but a planetary reconfiguration, an abrupt aridification that would test the foundations of every complex society it touched. The evidence is written in the layers of the Earth itself. cores drilled from ocean floors and ancient lakebeds tell a consistent story of suddenly drier conditions. Pollen records show forests retreating and dust levels rising. These are the fingerprints of a climate system under immense stress, and they align perfectly with a period of profound human upheaval. In Egypt, the lifeblood of the Old Kingdom was the predictable annual flooding of the Nile. It deposited rich silt and filled irrigation channels, a rhythm so reliable it formed the bedrock of pharaonic power. The 4.2 Kiloyear event appears to have disrupted this sacred cycle. Evidence suggests a period of significantly reduced Nile floods, a failure of the natural order that would have led to crop shortages and famine. The result was the end of the pyramid-building Old Kingdom and a descent into the fragmented, uncertain era known as the First Intermediate Period. Central authority dissolved and local governors took power, a story of fracture. Yet, Egypt's story did not end there. Its geography offered a unique form of resilience. The Nile was a single, concentrated artery of life in a vast desert. While the floods might fail, the river's course remained, and the cultural idea of a unified Egypt persisted. After a time of hardship, the society found a way to reconstitute itself, emerging as the Middle Kingdom. The outcome was starkly different far to the east, in the sprawling river basins of the Indus Valley. The Harappan civilization was a marvel of urban planning, with meticulously laid-out cities like Mohenjo-Daro and Harappa featuring advanced sanitation, standardized weights, and trade networks stretching to Mesopotamia. They, too, depended on river systems, primarily the mighty Indus and the now-vanished Gagga-Hakra. The same climatic aridification that stressed the Nile likely caused these rivers to shrink or become erratic. But here, the response was not fragmentation and eventual reunion. Instead, the archaeological record shows a gradual but decisive transformation. The great cities were not violently destroyed. They were slowly, systematically abandoned. The population appears to have dispersed into smaller, more mobile communities, shifting eastward toward the foothills of the Himalayas where rainfall was more reliable. This was not a collapse in the sense of a sudden catastrophe, but a deliberate, generations-long adaptation to a changing world. The grand urban experiment was set aside in favor of a more resilient, decentralized way of life. The contrast between Egypt and the Indus Valley presents one of history's great unresolved puzzles. Why did one civilization fracture and then remember how to be whole, while another chose to dissolve its grandest achievements and transform its very identity? The answer may lie in the nature of their foundations. Egypt was built around a singular, unchanging geographic feature, the Nile, which focused its culture and politics. When crisis came, the physical and cultural center remained, waiting to be revived. The Harappan world, while incredibly unified in culture, was built across a more complex and vulnerable river network. When those waters failed, the physical anchor for their urban model vanished, prompting a more fundamental reinvention. This global event forces us to look beyond local explanations for collapse. It reveals a world where climate could act as a universal trigger, a synchronizing metronome for human destiny. The true mystery is not why these societies were stressed, but how their deep-seated structures, their geography, and their cultural memories dictated the wildly different paths they took in response. Some broke and later mended, others simply chose to become something else entirely. The fate of the Indus Valley civilization presents a mystery of a different kind. There were no sacked palaces, no hastily built defensive walls, no caches of weapons pointing to a final, desperate battle. Instead, the archaeological record of its great cities, Mohenjo-Daro and Harappa, tells a story of quiet departure. Over generations, the meticulously planned streets, with their world's first known urban sanitation systems, fell silent. The standardized weights used for trade gathered dust. This was not an invasion, but an exodus, leaving behind one of history's most profound and elegant puzzles. How does a sophisticated society simply choose to walk away? The answer may lie in the disappearance of a mythic river. Ancient texts like the Rig Veda speak with reverence of the Saraswati, a mighty, life-giving river. For decades, scholars debated whether this was a purely mythological concept or a memory of a real place. Modern geological surveys and satellite imagery have revealed the ghost of a riverbed, a vast, dry channel running parallel to the Indus. This was likely the Saraswati, a river fed not by glacial melt but by the monsoon rains. And here, the climate record delivers a crucial clue. The same planetary aridification that stressed Egypt and Mesopotamia, the 4.2 Kiloyear event, appears to have pushed the Indian monsoon rains steadily eastward. As the rains shifted, the Saraswati's source waters gradually failed. What was once a roaring artery of civilization became a seasonal trickle, and then nothing but a memory in the sand. The impact of this hydrological collapse would have been slow, relentless, and total. Agriculture in the region depended on that river. As its flow diminished, fields would have produced less and less. The trade networks that connected inland cities to the coast, networks that moved precious stones, metals, and grains, would have withered as the economic reason for these cities evaporated. The very foundation of their complex urban life was not attacked, it was simply withdrawn. This leads us to the unresolved heart of the mystery. What did the people actually do? Was this a panicked, rapid abandonment as the last well ran dry, or something far more deliberate? The evidence points toward a managed, centuries-long adaptation. Archaeologists find that while the great urban centers were fading, smaller settlements began to appear to the east, in the foothills of the Himalayas and the upper reaches of the Ganges River basin. These were not grand cities but smaller, more agrarian communities. It seems the population did not vanish, they migrated. They carried their language, their technologies, and their cultural knowledge with them, but they left the urban model behind. This challenges everything we think we know about societal collapse. We imagine burning cities and fallen kings, a dramatic and tragic end. But the Indus Valley story suggests another possibility: transformation. Faced with an insurmountable environmental shift, the civilization may have made a collective, pragmatic decision. The grand project of city building was no longer sustainable, so they traded scale for resilience. They exchanged the vulnerability of a complex, water-intensive urban system for the flexibility of smaller, dispersed communities better suited to a new climatic reality. Their collapse was not an ending but a profound reorganization. It was a silent, strategic retreat from one way of life into another, forever altering the cultural landscape of South Asia and seeding the traditions that would follow. This silent exodus forces us to ask a difficult question. In the face of a changing world, is the greatest act of resilience sometimes to let go of what you have built, to transform rather than to fall? While some civilizations faded under a relentless sun, others were plunged into an unnatural cold. History holds accounts of years when summer never arrived, when frosts blackened fields in July and a dim, copper-colored sun hung in a hazy sky. These were not myths, but the brutal reality of volcanic winters, sudden and severe climate shocks delivered from the very heart of the planet itself. The mechanism is terrifying in its simplicity. A cataclysmic volcanic eruption can blast millions of tons of sulfur dioxide gas high into the stratosphere, where it transforms into a veil of reflective aerosols. This veil encircles the globe, scattering sunlight back into space and cooling the surface for years. We have a precise record of these global events locked in the ice of Greenland and Antarctica. Scientists drilling deep ice cores find layers with spikes of sulfuric acid, chemical fingerprints of ancient eruptions that darkened skies across continents. These layers are timelines of planetary trauma, and they align with some of humanity's most difficult chapters. One of the most consequential of these events was the colossal eruption of Thera, the volcano at the heart of the Aegean island now known as Santorini. Around 1600 years before the Common Era, Thera exploded with a force estimated to be many times greater than the famous Krakatoa eruption of 1883. The immediate local effects were apocalyptic. A tsunami of staggering height radiated outward, devastating the northern coast of Crete, the home of the sophisticated maritime Minoan civilization. Palaces and coastal settlements were swept away, but the disaster did not end with the wave. The eruption injected vast quantities of ash and aerosols into the atmosphere, likely triggering several years of cooler temperatures, poor harvests, and disrupted weather patterns across the eastern Mediterranean. For the Minoans, this was a 1-2 punch of unimaginable force. Their society, built on trade, naval power, and agricultural abundance, was crippled. While they were not immediately wiped out, the combined trauma of physical destruction and climatic stress fatally weakened their political and economic system, leaving them vulnerable. Within generations, their culture was absorbed by the rising Mycenaean Greeks from the mainland. Thera did not solely cause the end of the Minoans, but it acted as the ultimate stress test, one their damaged society could not pass. Centuries later, the entire world would experience a similar shock. In the year 536, a mysterious, persistent dry fog descended across Europe, the Middle East, and Asia. Contemporary chroniclers from Byzantium to China wrote of a sun that gave no more light than the moon, a darkness that lasted for 18 months. Temperatures plummeted. Snow fell in summer. Crops failed utterly from Scandinavia to the Mediterranean. This was the beginning of what some historians call the worst year to be alive in human history. Ice core evidence points to a massive, climate-altering volcanic eruption, with a leading candidate being the Ilopango volcano in what is now El Salvador. The global fallout was immediate and horrific. The failure of harvests led to widespread famine, a catastrophic weakening of populations, and in this moment of profound vulnerability, nature delivered a final blow. In 541, the first great wave of the Justinian plague erupted in the Eastern Roman Empire, spread by rats and fleas thriving in the disrupted climate. Combination of volcanic winter, famine, and pandemic may have killed tens of millions, hastening the end of the classical world and shaping the early medieval period. So what is the unresolved impact of these sky darkeners? They force us to ask a pivotal question about historical cause and effect. Did a volcano like Thera or the 536 event possess the unique power to single-handedly derail a stable civilization? Or were they merely the ultimate trigger, exposing and accelerating weaknesses that were already present, like a spark landing on a pile of dry kindling? The Minoans, for all their glory, may have already been facing internal or external pressures. The Roman Empire of the 6th century was overextended and politically strained. The volcanic winter did not create these problems, but it magnified them to a breaking point. These events remind us that human history is not written solely by kings and armies. It is also written by the deep, geological rhythms of the Earth itself, capable of delivering a knockout blow from its arsenal with no warning. In the face of such a force, the resilience of a society is tested not over decades, but in the desperate struggle to survive a string of cold, dark, and hungry years. The silence that followed volcanic eruptions was a prelude to an even greater unraveling. Around 1200 years before the Common Era, the entire interconnected world of the Eastern Mediterranean seemed to catch fire all at once. From the citadels of Mycenaean Greece to the Hittite strongholds of Anatolia and the bustling Canaanite ports along the Levant, a wave of destruction swept through. Palaces were burned, cities were abandoned, and writing systems were forgotten, plunging the region into a centuries-long dark age. This was the Late Bronze Age collapse, a catastrophic event that ended not just one civilization, but an entire international system. It stands as one of history's most enduring and complex mysteries, a perfect storm where climate did not act alone, but as a relentless multiplier of every other disaster. The evidence for a profound environmental shock is etched into the very growth rings of ancient trees. Studies of timber from Anatolia, the heart of the Hittite Empire, reveal a period of severe and prolonged drought in the decades leading up to the collapse. Sediment cores from the Dead Sea show a dramatic drop in water levels. This was not a single bad harvest, but a grinding, multi-generational crisis of aridity. Famine would have been a constant, haunting specter. An inscription from the Egyptian pharaoh Merneptah starkly notes, "I sustained the entire land with grain." This was not a boast of generosity, but a record of desperation, revealing that even the breadbasket of Egypt was struggling and being called upon to feed others. The foundation of these societies, their agricultural surplus, was crumbling. Into this landscape of scarcity came a force recorded only by their terrified victims, the Sea Peoples. Egyptian temple reliefs depict chaotic naval battles against a confederation of warriors and their families arriving on ships. For a long time, history framed them as mysterious, ruthless invaders. But a more compelling theory is now widely considered. What if the Sea Peoples were not the cause of the collapse, but a symptom of it? They may have been climate refugees, displaced from their own collapsing homelands, perhaps in the Western Mediterranean or Anatolia, by the same droughts and famines. Desperate and armed, they moved along the coasts, not as a coordinated army of conquest, but as waves of displaced people crashing against already weakened states, triggering a cascade of instability. This brings us to the unresolved heart of the debate. Was climate the primary driver, or merely the spark that lit a powder keg of human problems? The late Bronze Age world was a delicate, globalized system. It relied on intricate trade networks moving tin, copper, ivory, and luxury goods between empires. A prolonged drought would have shattered this economic web. No tin means no bronze, crippling both agriculture and the military. As famine spread, the social contract between the palatial elites and the people broke. Internal rebellions became likely. At the same time, warfare was changing. The use of massed infantry and new techniques may have undermined the old chariot-based aristocracies. So, which factor was decisive? The collapse serves as our most complex case study. It argues against a single, simple cause. Instead, it presents a terrifying synergy. Climate stress weakened the agricultural and economic base. This fragility made societies vulnerable to internal unrest and external pressure from displaced populations. The resulting warfare and systemic trade collapse then made recovery from the ongoing drought impossible. Each disaster fed the others in a vicious, inescapable cycle. The palaces did not fall to one enemy, but to a confluence of calamities that reinforced each other. This is the ultimate warning from the late Bronze Age. Highly interconnected civilizations can achieve remarkable things, but that same connectivity can become a conduit for shared catastrophe when multiple systems, both environmental and social, begin to fail at once. Their intertwined fates sank together. The collapse of interconnected empires stands in stark contrast to the story of a people who mastered isolation. Far from the Mediterranean world, in the sun-baked canyons of the American Southwest, the ancestral Puebloans, often called the Anasazi, built a civilization that was a breathtaking dialogue between architecture and the sky. Their monumental great houses at places like Choco Canyon were not just dwellings, but celestial calendars of stone, precisely aligned to the solstices and lunar cycles. This was a society that understood its place in the cosmos, yet by the 13th century, these magnificent centers were left silent. Their departure was not the result of foreign invasion, but of a relationship with a landscape that slowly, irrevocably changed. The story here is not of a sudden cataclysm, but of a long, ingenious struggle against a drying world, a struggle that ultimately reached its limit. We know the precise rhythm of this environmental change because the region's ancient trees kept a perfect diary. Dendrochronology, the science of reading tree rings, reveals a devastating climatic chapter. Starting around the year 1275, the Colorado Plateau was gripped by a period known as the Great Drought, a span of more than 2 decades where rainfall was not just scarce but persistently, punishingly absent. These narrow, stressed rings in the wood tell a story of failing springs and parched fields, but the ancestral Puebloans were not passive victims of this trend. They were hydrological geniuses in a land where every drop was sacred. Across the mesas, they constructed intricate systems of check dams and terraces to capture and slow the rare runoff from rainstorms, guiding precious soil and water to their fields. At Choco, they engineered massive underground reservoirs and canals to collect water from miles around. Their entire settlement pattern was a form of water harvesting, a testament to deep observation and adaptation. So why, after centuries of such clever resilience, did they finally leave? The unresolved impact of the Great Drought lies not in a simple failure of engineering, but in its profound social and spiritual consequences. A drought lasting a generation is more than an environmental event. It is a psychological and cultural trauma. When the carefully managed systems began to fail under a sky that offered no relief, the very foundation of their society was questioned. The great houses and their precise astronomical alignments were likely centers of ritual and authority, places where religious leaders mediated between the people and the forces that brought rain. When the rains did not come, despite the correct ceremonies and alignments, that authority would have crumbled. Trust in the social and spiritual order would have evaporated as quickly as the last puddle in a reservoir. This likely led to a painful fracturing. Some archaeologists point to evidence of increased conflict in this period, not large-scale warfare, but perhaps raiding and violence between communities competing for dwindling resources. The concentration of people in great centers like Choco may have become unsustainable, even dangerous. The response, then, was not a chaotic rout, but what appears to be a purposeful, organized migration. Families and clans gradually moved away from the canyon heartlands, dispersing to areas with more reliable water sources, like the Hopi Mesas in Arizona and the lands along the Rio Grande in New Mexico. They took their knowledge, their pottery styles, and their stories with them. This is where their legacy fundamentally challenges our idea of a vanished civilization. The story of the ancestral Puebloans does not end with empty ruins. It continues in the living cultures of the modern Pueblo peoples, including the Hopi, the Zuni, and the Rio Grande Pueblos. Their great migration was not an ending but a transformation, a strategic decision to preserve their community by relocating its heart. The civilization, as a centralized canyon-dwelling phenomenon, did cease. But the people and the core of their culture persisted, adapting and evolving in new homes. This is a vital concept for rethinking all historical narratives of loss. It reminds us that sometimes the ultimate act of resilience is not to stand firm against an impossible change, but to make a collective choice to move, carrying your identity with you into a new chapter. Their story is not one of disappearance, but of profound continuity written across a vast and demanding landscape. Their story of migration reveals a profound truth about survival through flexibility. But what happens when a culture chooses the opposite path? On the windswept, rocky shores of Greenland, a different kind of mystery played out. One where the greatest threat was not a changing landscape, but an unchanging mind. In the late 10th century, Norse settlers arrived from Iceland, led by the fiery Eric the Red, who gave this vast island its deceptively hopeful name. They found fjords that were, for a time, genuinely green. This was the tail end of the medieval warm period, a climatic anomaly that made this northern frontier just barely habitable for their way of life. They established two main settlements, the eastern and western, building stone churches, raising cattle and sheep, and replicating a pastoral European society at the very edge of the known world. For centuries they persisted, a lonely outpost of medieval Christendom. Then, by the middle of the 15th century, they were gone. The last written record is a wedding description from 1408. After that, only silence. Their fate is not a dramatic tale of sudden catastrophe, but a chilling story of a slow, stubborn fade into oblivion. The climate once again set the stage. As the medieval warm period waned, the Little Ice Age began its gradual grip on the North Atlantic. Ice cores from Greenland itself tell the story of a creeping cold. Layers of ice show increasing amounts of sea salt, indicating more stormy weather and longer seasons of pack ice blocking the vital sea lanes to Iceland and Norway. Soil samples from the Old Norse farmsteads reveal a landscape growing colder and less fertile, the thin soil degrading as the growing season shortened year by year. The world around them was becoming harsher, more isolated, and less able to support their chosen lifestyle. And here we encounter the heart of the puzzle. The Norse were not alone in Greenland. The Thule Inuit, ancestors of the modern Inuit people, thrived in the same environment even as it cooled. Their adaptation was a masterpiece of efficiency, centered on hunting ringed seals and whales from kayaks and umiaks, using every part of the animal for food, fuel, clothing, and tools. They lived in mobile, communal sod houses following the resources. The Norse, by stark contrast, remained committed to their identity as Scandinavian farmers. They lived in individual, timber-poor stone houses that were difficult to heat, and they focused a tremendous amount of their energy on maintaining livestock, which required winter fodder that became increasingly scarce. The archaeological record is strikingly clear on this cultural divide. While Inuit sites contain Norse-made iron items, likely traded or found, there is almost no evidence that the Norse adopted key Inuit technologies. No harpoon heads appear in Norse middens, no evidence of seal hunting kayaks. They ate some seal, but largely from beached animals, not active hunting. Their diet remained heavily dependent on their struggling cattle and on imported grain from Europe, a supply line that became ever more treacherous as the sea ice expanded. Why this refusal to adapt? The unresolved impact of their collapse is a profound lesson in cultural inertia. Their society was built on a specific hierarchy, with wealthy landowners defined by their cattle and their connection to European ecclesiastical authority. To abandon cattle farming for seal hunting was not merely a practical shift, it was a social and spiritual demotion. It would mean abandoning their identity as Europeans, as Christians living in a structured society, and adopting the ways of a people they likely saw as pagan scralings or wretches. Their worldview, their very sense of who they were, became a cage. The environment changed, but their cultural template did not. This forces us to confront a difficult question. Was their disappearance an inevitable result of a cooling climate, or was it a choice? Given the proven success of the Inuit lifestyle, the resources for survival were physically present all around them. Their collapse, therefore, seems shaped less by absolute scarcity and more by a rigid ideology that filtered what they were willing to see and what they were willing to become. It is a haunting reminder that the stories we tell ourselves about who we are can sometimes blind us to the paths that lead forward. In the end, the Greenland Norse did not vanish because the world became impossible to live in. They faded because the world they were determined to live in, the one in their minds, no longer existed. The story of the Greenland Norse is a stark lesson in cultural rigidity, but their fate was part of a much larger climatic story unfolding across the entire northern hemisphere. A great chill was descending, a climatic epoch we now call the Little Ice Age. Beginning roughly in the 14th century and lasting into the 19th, This was not a true ice age, but a prolonged period of cooler temperatures and erratic weather that reshaped societies from Europe to Asia. This more recent chapter in our climate story acts as a powerful laboratory, showing us with remarkable clarity how even a modest drop in average temperature, perhaps just 1 or 2 degrees Celsius, can send shock waves through the very foundations of civilization. The evidence was written in the landscape itself. Alpine glaciers advanced relentlessly, swallowing pastures and villages. In winters so severe they became legend, the River Thames in London froze solid enough to host elaborate frost fairs, complete with temporary shops and ice skating, a spectacle born of profound cold. This shift was driven by a confluence of natural factors, including a period of reduced solar activity known as the Maunder minimum, and a series of major volcanic eruptions that pumped sun-blocking aerosols into the stratosphere. The combined effect was a world growing colder, stormier, and less predictable for generations. The most immediate and universal impact was on the food supply. Agriculture in pre-industrial societies lived at the mercy of the growing season, and that season was shrinking. Cooler summers and early autumn frosts led to repeated crop failures. The first great catastrophe of this era was the Great Famine of 1315 to 1317. Across Europe, years of relentlessly cold, wet weather rotted grain in the fields. The price of food skyrocketed, and chroniclers of the time described desperate scenes of hunger, with some reporting that people turned to eating roots, tree bark, and even family pets. This was not a localized event but a continent-wide trauma that killed millions and left societies deeply vulnerable. In such an atmosphere of fear and scarcity, the human need to find a cause, a reason for the suffering, became intense. Historians note that the subsequent centuries saw a tragic and dramatic rise in witch-trial panics, particularly in regions of extreme climatic stress like parts of Germany and Switzerland. When rational explanations failed, communities often turned inward, seeking supernatural culprits for the blighted harvests and unexplained illnesses. A heartbreaking example of how climate stress can warp social logic and target the marginalized. The instability did not stop at famine and social fear. It escalated into political and military catastrophe. The prolonged climatic hardship of the 17th century created a tinderbox of resource competition and social strain. Many scholars see the fingerprints of the Little Ice Age on the devastating 30 Years' War, a conflict that ravaged Central Europe from 1618 to 1648. While fundamentally a religious and political struggle, the war was fought by armies that had to live off the land. Successive harvest failures made this impossible, turning military campaigns into exercises in brutal foraging that devastated the countryside and led to catastrophic population loss. The climate did not cause the war, but it dramatically amplified its horror and scale, making recovery nearly impossible for decades. This pattern of climate as amplifier was global. In Ming Dynasty China, a period of pronounced cooling coincided with severe droughts in the north and floods in the south, leading to widespread crop failure and famine. This environmental stress exacerbated existing social tensions and economic problems, contributing to the peasant rebellions that ultimately helped topple the dynasty in 1644. A changing climate rarely invents new conflicts, but it consistently loads the dice, making existing fractures far more likely to break. The ultimate insight from this more recent period is one of profound nonlinearity. A global temperature shift of just a degree or two seems almost trivial on a thermometer, but in the complex, interconnected systems of human society, its effects are anything but small. It shortens growing seasons, shifts rainfall patterns, and increases the frequency of extreme weather events. These changes then cascade through food systems, economies, and political institutions. They trigger migrations, inflame resource competition, and undermine the legitimacy of governments that cannot ensure basic sustenance. the Little Ice Age demonstrates with terrible clarity that climate is never merely a backdrop. It is an active, persistent force in human history, a slow-moving current that can gradually erode the banks of social order until they finally give way. This brings our journey from the ancient world into a more familiar historical frame, setting the stage for the most pressing question of all. If societies from Arcadia to Greenland were so vulnerable to shifts they could neither predict nor control, what does that mean for our globally connected world today, facing a change that is not a natural cycle, but one of our own making? The slow chill of the Little Ice Age reshaped continents, but across the world another empire faced a different kind of climatic betrayal. At the heart of Southeast Asia, the Khmer Empire reached a zenith of power and artistry that seems almost superhuman. Its crown jewel, Angkor, was not merely a collection of temples, but a vast, engineered landscape, a hydraulic city on a staggering scale. Canals, reservoirs, and moats stretched for hundreds of square miles, a machine designed to capture, store, and distribute the lifeblood of the region, the annual monsoon rains. This system fed the rice paddies that sustained a population of perhaps 1 million people and powered the empire that built Angkor Wat. Yet from the 14th century onward, this magnificent machine began to falter, and the great city was gradually reclaimed by the jungle. For a long time, the story was one of mysterious abandonment. Now, the mud at the bottom of Angkor's own moats is telling a different tale. Sediment cores extracted from these ancient waterways act as a climate diary. The layers of silt and pollen reveal a pattern not of steady decline, but of violent instability. Decades of severe drought where the monsoon rains failed to arrive are recorded in thin, parched layers. These are abruptly followed by evidence of catastrophic flooding, immense deluges that would have overwhelmed the carefully calibrated system. This volatility was a nightmare for the Khmer engineers. Their infrastructure was a masterpiece designed for a predictable rhythm of abundance, a reliable pulse of rain followed by a dry season. What it could not withstand was a climate that had become erratic, swinging between punishing aridity and destructive inundation. A prolonged drought would see the massive reservoirs like the West Barre, which could hold over 50 million cubic meters of water, drop to dangerous lows. The following intense monsoon would then rush in, carrying with it enormous loads of eroded soil, potentially clogging the very canals and spillways meant to control it. This leads us to a compelling physical mystery. Could the system have literally silted itself to death? Over centuries, the deforestation and land use required to support such a huge population would have increased soil erosion. During those intense floods, this silt would have been dumped into the canals and reservoirs, gradually reducing their capacity. Maintaining such a vast network required constant, organized labor to dredge and repair. If the climate shocks made agriculture increasingly unreliable, the state may have found it harder to command the labor force needed for this endless upkeep. The technological marvel that defined their civilization could have become a millstone, its maintenance costs exceeding the benefits it provided in an increasingly unpredictable climate. But there is another, more subtle layer to this story, one found not in sediment but in spirituality. During this same period of environmental stress, a profound religious shift was taking hold. The empire's state religion, which centered on the divine authority of the god-king responsible for ensuring cosmic and earthly order, including the rains, was gradually being supplanted by Theravada Buddhism. This newer faith emphasized personal enlightenment and individual merit over grand state-sponsored rituals. This raises a haunting, unresolved question. Did this change in belief contribute to the walking away from the hydraulic machine? If the king was no longer seen as the essential intermediary between the people and the forces of water, then the imperative to maintain his colossal waterworks as a sacred duty might have faded. The societal energy and resources required for such a monumental task may have been redirected inward toward personal spiritual pursuits and smaller, community-based temples. It was not that people forgot how to maintain the canals, but that they may have collectively decided it was no longer the most important thing to do. The case of Angkor forces us to consider a civilization's trajectory as a three-way conversation. Environmental stress in the form of a failing monsoon applied immense pressure. Technological overreach, the creation of a system so vast it required constant Herculean effort to sustain, created a profound vulnerability. And cultural change, a shift in the very beliefs that bound society together, may have altered the collective will to fight that battle. The jungle did not simply conquer a city. It filled the spaces left behind when a society, facing a changing world, began to tell itself a new story about what mattered most. The silent stories of vanished cities and abandoned fields would remain forever locked in myth, if not for the silent witnesses all around us. To understand these past climates, we must learn to read a language written not in words, but in atoms, trapped air, and ancient dust. This is the domain of paleoclimatology, a field that acts as planetary forensics, using natural archives called proxy data to reconstruct the weather of a world before human record-keeping began. These proxies are not direct measurements but physical records that respond in predictable ways to environmental change, allowing scientists to translate the past. Consider the immense ice sheets of Greenland and Antarctica. Each year, a new layer of snow falls, trapping tiny bubbles of the atmosphere within it. Over millennia, this snow compresses into ice, creating a vertical timeline stretching back hundreds of thousands of years. Scientists drill deep ice cores, extracting these frozen columns of history. Within them, they analyze the ratio of different oxygen isotopes in the water molecules themselves. A higher proportion of a lighter oxygen isotope generally indicates a warmer climate when that snow fell, while more of a heavier isotope points to colder conditions. The tiny air bubbles are even more direct. They are literal samples of the ancient atmosphere, allowing us to measure past levels of greenhouse gases like carbon dioxide and methane. An ice core is a frozen library, its pages written in chemistry, telling the story of global temperature and atmospheric composition year by year, century by century. On land, another patient chronicler stands sentinel, the tree. Each growing season, a tree adds a new ring of wood beneath its bark. In temperate regions where growth is seasonal, each ring represents 1 year. The width and density of that ring are a diary entry of that year's conditions. A wide, robust ring tells of a warm, wet-growing season with abundant resources. A narrow, stressed ring whispers of drought, cold, or insect damage. By taking core samples from living ancient trees, like the bristlecone pines of North America, and cross-referencing their patterns with timber from ancient buildings or buried logs, scientists can build continuous tree ring chronologies or dendroclimatic records stretching back thousands of years. This gives us an annually resolved record of regional moisture and temperature with astonishing precision, allowing us to pinpoint the exact year a great drought began in the American Southwest or a volcanic winter chilled Europe. Beneath the waves and at the bottoms of ancient lakes, other archives accumulate. In the deep ocean, a constant, gentle rain of microscopic plankton shells and sediment settles on the seafloor, building up layer by layer over eons. Core samples from these ocean muds can be analyzed for the chemical composition of those tiny shells, which changes with the temperature of the water the organisms lived in. Shifts in the types of pollen grains preserved in lakebed sediments are equally revealing. Pollen is incredibly durable. By identifying which plants the pollen came from, scientists can map how forests, grasslands, and deserts expanded or retreated as the climate changed. A layer rich in spruce pollen followed by a layer dominated by oak pollen tells a clear story of warming. These proxies from ice to mud work together like pieces of a global puzzle. A volcanic eruption recorded as an acid layer in an ice core in Greenland can be matched to a period of narrow tree rings in Europe and evidence of crop failure in historical texts. This convergence of evidence is what gives us confidence in the reconstructions of past climate shifts. It transforms speculation into a detailed, physical narrative. We are not imagining these ancient droughts and cold snaps, we are reading them, measured in parts per million in an ice bubble, counted in the millimeters between tree rings, and seen in the changing dust of a 1,000-year-old lakebed. This rigorous detective work is the foundation upon which our entire understanding of climate's role in history is built, allowing us to listen to the Earth itself recount its turbulent past. The evidence from ice cores and tree rings gives us a powerful tool, but it also presents us with a profound interpretive challenge. We can measure the drought that struck the Maya or the cold that gripped the Norse, but how do we measure the human response? Our language itself may be leading us astray. The very word collapse, so often used to describe these historical moments, carries a weight of finality and catastrophe. It paints a picture of a single dramatic event, of ruins standing empty against a silent sky. But for most of the societies we have explored, that image is a dramatic oversimplification, one that can blind us to the more complex and often hopeful truths of human resilience. What if we have been misreading the endings? For many early societies, the end of political centralization or the abandonment of grand urban centers did not mean the end of the people or their culture. It often meant a profound change in strategy. Scholar Joseph Tainter offers a compelling lens for this. He suggests that societies, as they grow, develop increasingly complex solutions to their problems, from bureaucratic administration to monumental infrastructure. This complexity works wonderfully until it begins to cost more in energy and resources than the benefits it provides. Then, under a stress like a prolonged drought or cooling climate, that overbuilt system can become a burden. The solution is not always to fight to maintain it at all costs, but sometimes to let that specific form of complexity go, to simplify, to reorganize. This is not a failure of intelligence, but a pragmatic adaptation to new realities. We can see this reframing in action with societies we have already met. Take the so-called fall of the Western Roman Empire. The political entity centered on Rome dissolved, its legions and tax collectors vanished. But the people of Gaul, Iberia, and Italy did not vanish. They reorganized into new kingdoms, blending Roman law and infrastructure with new cultural influences. The complex empire-wide system gave way to smaller, more localized forms of governance, a dispersal of power that was chaotic, but also creatively fertile, eventually giving rise to the nations of medieval Europe. Similarly, the classic Maya collapse in the southern lowlands was not an extinction. It was a geographic and political shift. Power and population moved north into the Yucatan Peninsula, where cities like Chichen Itza and Uxmal rose to prominence in the post-classic period. The cultural knowledge, the calendar, the spiritual beliefs, they traveled with the people. The civilization transformed, it did not die. This conceptual shift is vital. It moves us from a simplistic narrative of tragic failure to a more nuanced story of adaptation and continuity. When we look at the silent cities of the Indus Valley or the empty great houses of Choco Canyon, we are not looking at graveyards. We are looking at waypoints. They mark a moment when a community made a collective decision that the current path was no longer sustainable and chose a different one. The unresolved impacts of past climate shifts, then, are not dead ends in human history. They are forks in a long and winding road. They represent moments of painful but necessary simplification, of strategic retreat, of cultural migration. The story is not that a civilization ended, but that it changed its address and in doing so changed its form. This reframing does not diminish the very real hardship and loss those generations endured. but it does grant them a dignity and agency that the word collapse often steals from them. It allows us to see them not as victims of their environment, but as active participants in an endless dialogue with a changing world, making difficult choices to ensure that their story, in some form, would continue. The choices societies make in the face of a changing world are written in the paths they walk away from, and the ones they choose to follow. Yet on the arid coast of Peru, a different kind of climatic story unfolded, one not of gradual pressure but of sudden, overwhelming violence. The Moche civilization flourished for centuries in a landscape where rain was almost a myth. They channeled scarce river water through intricate canals to farm narrow valleys, and with this agricultural wealth they built immense adobe pyramids, the Huacas del Sol and de la Luna, that still dominate the desert. They were master metalworkers and ceramic artists, creating vessels with stunning realism that depicted their gods, their rituals, and their world. Then, around the 6th century of the Common Era, their sophisticated society fragmented. The cause was not an invading army, but a familiar Pacific phenomenon pushed to a nightmarish extreme: El Niño. The El Niño Southern Oscillation is a natural cycle where warm water shifts east across the Pacific, altering weather patterns globally. For the coast of Peru, a typical El Niño can mean welcome rains, but the geological record at Moche sites tells a story far beyond typical. Archaeologists digging through the layers of history find startling evidence: thick strata of chaotic sediment, cobbles, and clay that can only be explained by catastrophic flooding. These are not gentle river overflows, but walls of water and mud roaring down from the Andes, unleashed by torrential rains in the desert mountains. Imagine the impact on a landscape of sun-dried brick and carefully engineered canals. Irrigation systems would have been obliterated in hours, fields buried under meters of sterile debris, and storehouses ruined. The very infrastructure of life was washed away. But the climatic assault was not a single event. The sediment layers reveal a terrifying pattern. Periods of these devastating floods are followed by evidence of prolonged, severe drought. This is the cruel duality of an intensified El Niño cycle. The system swings from one extreme to the other, leaving no time for recovery. A society could perhaps rebuild after a great flood, but to then face decades of rainless skies with their rebuilt canals sitting empty and their soil parched would break any agricultural system. The Moche were caught in a climatic vise, squeezed between floods that destroyed everything and droughts that prevented anything from growing again. This physical devastation would have triggered profound social and spiritual crisis. The Moche worldview was intimately tied to the forces of nature. Their art is filled with depictions of a powerful deity often called the Decapitator, a fanged figure associated with mountains, water, and fertility. The authority of the priestly elite was likely based on their perceived ability to mediate with this being, to ensure the flow of water and the success of the harvest. What happens when those rituals fail, not just once but repeatedly? When the gods you believe control the weather instead deliver indiscriminate destruction followed by barren silence? The result could have been a catastrophic loss of faith in the entire social and religious order. The magnificent ceremonial centers, the Huacas, may have been seen not as places of power but as monuments to a broken covenant. Archaeological evidence suggests that over time these centers were abandoned, with power shifting to smaller, more dispersed valley settlements. The unresolved impact of the Moche collapse forces us to look at climate shifts through a different lens. This is not a story of a gradual temperature change or a slowly encroaching desert. It is a story of volatility, of the increasing frequency and intensity of extreme weather events. The Moche were experts at managing scarcity, but their systems were not designed for climatic whiplash. Their experience is a stark, ancient echo of a modern pattern, where the greatest challenge may not be the change in average conditions, but the destabilizing surge of disasters that leave no breathing room to adapt. It raises a haunting question about resilience. How do you prepare for a world where the rules of the sky itself become unpredictable and violent? The fate of a society under climatic pressure was never written in the weather alone. It was written in the choices made generations before the first rains failed. Faced with similar droughts and freezes, why did some civilizations shatter like glass while others bent, adapted, and found a new shape? The answer lies not in the shock itself, but in the deep architecture of the society that received it. Resilience and vulnerability are not random traits. They are cultivated, often invisible, until a moment of crisis reveals them. By comparing those who fell with those who transformed, we can begin to build a framework for understanding what truly makes the difference. First, consider diversity, both on the plate and in the power structure. A civilization that relies on a single staple crop or a single source of water is playing a dangerous game. The Akkadian Empire, with its vast, centralized irrigation feeding endless fields of grain, was a masterpiece of efficiency. But when the rain stopped across the entire region, that efficiency became a single point of catastrophic failure. Contrast this with the Indus Valley civilization. While they had major cities, their economy appears to have been built on a more diverse base, including trade in goods from distant regions, various crops, and likely different modes of subsistence. When their rivers shifted, this diversity of resources and connections may have provided more options, more pathways for communities to pivot and survive. Closely tied to this is flexibility in governance and technology. A rigid, top-down system where all decisions flow from a central authority can struggle to respond to local crises. The Greenland Norse, clinging to their identity as European pastoralists, refused to adopt the proven, flexible hunting technologies of the Inuit, even as their own way of life became impossible. Their cultural template was fixed. Now, look at a society like the Inca, who came later in the Andes. They faced a volatile climate, but they invested in what scholars call landscape capital, immense projects like the agricultural terraces that cascade down mountainsides. These were not just for one season's harvest, they were long-term investments that reduced erosion, created microclimates, and stabilized food production across generations. This represents a flexible, adaptive relationship with the environment, one focused on managing risk over the long term. Perhaps the most intangible yet vital factor is social cohesion and collective memory. A society with strong community bonds and a shared story can better organize for mutual aid during hardship. It can also draw upon cultural memory, stories of past famines or migrations to guide its response. The ancestral Puebloans, when faced with the Great Drought, did not descend into permanent chaos. Their dispersal appears to have been a coordinated, community-based decision to migrate to where water was more reliable, carrying their knowledge with them. Their social fabric, while stressed, held together enough to manage a strategic retreat. On the other hand, a society where the ruling elite is profoundly disconnected from the people, where the social contract is based solely on the ruler's ability to deliver prosperity, can fracture quickly when that prosperity fails. The legitimacy of Akkadian kings or Maya divine rulers evaporated with the rains, leaving a vacuum filled by fear and conflict. Insights from researchers like Jared Diamond and modern resilience theory point to a crucial conclusion: vulnerability is often a pre-existing condition. The climate shift is the test, but the score was written long before. A civilization already straining its resources, already divided by inequality, or already locked into rigid ideological systems, is primed for trouble. The shock simply reveals the cracks that were already there. This leads us to the most profound lesson from all these stories. A civilization's fate was often determined less by the severity of the drought or the cold snap, and more by the quality of its relationship with its environment and its own capacity for learning, change, and collective action. The environment posed the question, but the society, through its choices, wrote the answer. This understanding shifts our gaze from ancient weather patterns to the human heart of the story, and it raises a final, inevitable question about our own modern world, a world more interconnected and complex than any empire of the past. The silent ruins and abandoned fields left behind a different kind of evidence, one not written in stone or ice, but in story. When a community survives a trauma that reshapes its entire world, the memory of that event does not simply fade. It is woven into the very fabric of its identity, transforming over generations from lived experience into sacred myth. This is perhaps the most intimate and unresolved legacy of ancient climate shifts, a psychological imprint passed down through the ages. Around the globe, cultures separated by vast oceans share strikingly similar narrative cores, tales of overwhelming floods, punishing winters, and lost golden ages. The Babylonian epic of Gilgamesh, one of humanity's oldest written stories, describes a great flood sent by the gods to wipe out mankind, with a righteous man named Utnapishtim building a boat to save his family and the seeds of life. The parallels to the later Hebrew story of Noah are unmistakable. In the ancient Indian text, the Satapatha Brahmana, a man named Manu is warned by a fish of a coming deluge and builds a ship. From the Americas to the Pacific Islands, flood narratives appear with remarkable consistency. While these are often interpreted as purely theological, their widespread presence suggests a shared, deep-seated memory of a real and terrifying event. What could have been so globally traumatic as to echo for thousands of years? One compelling candidate is the rapid sea level rise that followed the last ice age. As the great glaciers melted, global sea levels rose by over 120 meters, drowning vast coastal plains that were once home to early human populations. This was not a slow, imperceptible creep, but a series of rapid pulses that could have swallowed entire landscapes within a few lifetimes. For communities living on those lost shores, the advancing ocean would have been an unstoppable, godlike force, a definitive end to one world and the beginning of another. The memory of those drowned homelands of a time when the sea was farther away could have fossilized into a universal story of divine punishment and survival. Similarly, myths of a great winter or a long period of darkness resonate with the climatic shocks we have already explored. The Norse myth of Fimbulwinter, a 3-year winter that precedes the apocalyptic battle of Ragnarok, could be a cultural memory of a severe volcanic winter or the abrupt cold of the younger Dryas. The Greek legend of a lost golden age, followed by successively harsher eras of silver and bronze, ending in an age of iron filled with hardship, reads like a poetic metaphor for a deteriorating climate and the struggles of early agricultural societies. These stories served a profound purpose. They were not mere entertainment, but frameworks for understanding a capricious and often dangerous natural world. By attributing a flood or a famine to the actions of gods or the moral failings of humanity, our ancestors created a system of meaning. It was less terrifying to believe the world was governed by divine beings who could be appeased through ritual than to accept it was governed by random, impersonal climatic forces. This worldview, born of trauma, shaped human civilization for millennia, influencing laws, ethics, and our relationship with nature itself. The idea that environmental catastrophe was a form of divine punishment became a powerful tool for social control and a lens for interpreting misfortune. Reading these myths as a kind of cultural proxy data offers us a unique insight. It allows us to glimpse not just the physical event, but its emotional and spiritual aftermath. The recurring theme of a survivor chosen to rebuild speaks to a hard-won lesson in resilience. The motif of a lost paradise reflects a deep nostalgia for a stable, abundant past that may have been real. These stories are the echoes of our ancestors' most desperate questions, asked in the shadow of a changing sky. They represent humanity's first attempt to answer the unresolved why, to find pattern and purpose in the chaos of a climate that could turn against them without warning. This legacy of myth demonstrates that the impact of an ancient drought or flood did not end when the rains returned. It continued to shape how generations of people saw their place in the universe, a psychological scar that became a cornerstone of culture, reminding us that the stories we tell about our past are often maps of our oldest fears and our deepest survival. The psychological legacy of myth connects us to a world shaped by water and sky, but the physical evidence of that connection lies waiting beneath our feet. On the broad floodplains of the Mississippi River, just across from modern-day St. Louis, the silent grass-covered pyramids of Cahokia rise from the earth. 1,000 years ago, this was not a quiet monument but the throbbing heart of a continent, a metropolis that at its peak around the year 1100 held a population that may have rivaled contemporary London. Its centerpiece was Monk's Mound, a colossal earthen pyramid larger at its base than the Great Pyramid of Giza, flanked by a grand plaza and over 120 smaller mounds. This was a city of astronomers, artists, and farmers, a sophisticated political and spiritual hub that connected trade networks from the Great Lakes to the Gulf of Mexico. Yet by the 14th century, the plazas fell silent, the great mounds stood empty, and the forest began its slow reclamation. The mystery of Cahokia's abandonment presents a powerful new world echo of the ancient patterns we have seen, a story of a society whose brilliant adaptation to a rich environment was ultimately tested by that environment's volatility. The lifeblood of Cahokia was the Mississippi River and the fertile black soil it deposited across the American bottom floodplain. Here, the people perfected the Three Sisters agricultural system, cultivating maize, beans, and squash together in a sustainable, highly productive symbiosis. This agricultural surplus fueled the city's growth, supporting not just farmers but the priests, chieftains, and craftspeople who built its monumental landscape. Cahokia was a testament to human ingenuity in a land of plenty, but that very plenty depended on a delicate balance, a predictable rhythm of spring floods to replenish the soil and summer rains to nourish the crops. When that rhythm broke, the foundation of everything they had built began to tremble. The tree rings of ancient oaks from the region tell a story of increasing instability. In the 12th and 13th centuries, the data reveals a punishing climatic 1-2 punch. First came periods of catastrophic flooding. The Mississippi, swollen by intense rainfall upstream, would have burst its banks with unusual force, not just enriching the soil but scouring fields, drowning young crops, and potentially washing away entire seasons of labor. These were not the gentle, fertility-bringing floods of legend, but destructive events that could erase the food base of a densely populated city. Hard on the heels of these deluges, the climate would often swing to the opposite extreme, into severe drought. The rings grow narrow and stressed, indicating summers where the rain simply failed, and the sun baked the already damaged fields. For a society utterly dependent on maize agriculture, this volatility was a nightmare. A single bad year could be weathered, but repeated cycles of flood and drought, destroying seed stores and straining communal granaries, would create a relentless pressure that no political system could easily withstand. The unresolved question that hangs over Cahokia's silent mounds is not just why people left, but where they went and what they carried with them. There is no evidence of a mass loss of life or a sudden, violent end. Instead, archaeology suggests a gradual dispersal. Over perhaps a generation or two, the population seems to have fanned out from the urban center, moving into smaller, more sustainable communities along the river's tributaries and into the surrounding uplands. This pattern strongly suggests that the people of Cahokia were not vanquished, but made a collective, pragmatic decision to simplify. the immense social and labor cost of maintaining a centralized city with its huge mounds and dense population may have become untenable in the face of climatic unpredictability. By dispersing into smaller, more flexible groups, they could reduce risk, diversify their food sources, and adapt to a changing landscape. This leads to a profound and enduring legacy. Many scholars see Cahokia not as a dead end, but as a cultural fountainhead. The people who walked away from the great mounds did not vanish from history. They likely carried their knowledge, their spiritual beliefs, and their social networks with them. The tribal nations encountered by European explorers centuries later in the Midwest and Southeast, from the Quapaw to the Chickasaw and many others, may well be the cultural and literal descendants of the Cahokian diaspora. Elements of the southeastern ceremonial complex, a shared set of artistic symbols and religious ideas found across the region in later centuries, may have roots in the iconography and rituals developed at Cahokia. If this is true, then Cahokia's story is one of transformative dispersal, not collapse. The city's power dissolved, but its influence rippled outward, seeding the cultural landscape of an entire continent. It stands as a final, powerful reminder that in the face of environmental pressure, the most resilient response is sometimes to let a singular, magnificent form go, so that the essence of the culture can live on in new and adaptable ways. The silent mounds of Cahokia remind us that endings are also beginnings. We have traced the arc of societies strained to their limit by a changing climate, but this is only half the story. For every civilization that simplified or dispersed under pressure, another form of human ingenuity was waiting in the wings. The chaos of a climatic breakdown did not always lead to a dark age of loss. Sometimes it cleared the ground for something entirely new to grow. This is the concept of creative destruction, where the collapse of an old, rigid order creates the open space necessary for bold experimentation. The turmoil that ends one chapter can be the very catalyst that starts the next. Consider the world left in the wake of the late Bronze Age collapse. The great imperial systems of the Hittites, Mycenaeans, and Egyptians had fractured, their complex palatial economies and cumbersome syllabic writing systems fading with them. Into this power vacuum stepped new players, societies built for agility rather than sheer scale. Along the coast of the Levant, the Phoenician city-states like Tyre and Sidon emerged not as land-based empires, but as masters of the sea. Unburdened by the need to feed vast inland populations, they turned crisis into opportunity. They built networks of trade colonies across the Mediterranean, moving goods, ideas, and technologies. Critically, they perfected an alphabet of simple symbols representing sounds, a system far more accessible than the complex scribbled scripts of the fallen empires. This revolutionary tool for record-keeping and communication would later be adapted by the Greeks, becoming a cornerstone of Western thought. The political landscape shifted too. In Greece, the fall of the Mycenaean palaces gave way to the independent polis, the city-state. These smaller, more participatory communities, while often in conflict with one another, became laboratories for new forms of politics, philosophy, and civic identity. The rigid hierarchies of the Bronze Age were replaced by a messy, competitive, and incredibly fertile world of innovation. The climate shock that helped topple the old giants did not cause these developments directly, but it shattered the status quo, making such radical reinvention possible. Centuries later, a similar pattern unfolded at the other end of the Mediterranean. The stability of the Roman Empire was underpinned by a period known as the Roman Warm Period, a climatic optimum that supported agricultural abundance across its territories. As that warm phase gradually ended, contributing to the pressures of the 3rd century crisis and beyond, the empire's structure transformed and eventually fragmented in the West. The so-called fall of Rome is often painted as a catastrophe, a plunge into darkness, Yet from this fragmentation emerged the diverse kingdoms of early medieval Europe. The unifying, top-down system of Rome gave way to localized power, customary law, and new social contracts between warriors, farmers, and a growing church. This was not merely a decline, but a profound reorganization. The movement of peoples during this era, often driven by climatic pressures further east, mixed cultures and technologies in new ways. The feudal system that emerged, for all its inequalities, was an adaptation to a world of lower population density, localized economies, and the need for community-based defense. It was a different answer to the question of how to organize society, born from the ashes of a system that could no longer be sustained. This reframing forces a vital shift in perspective. A climate shift is not merely a destructive force, it is a disruptive one. It breaks apart entrenched systems, redistributes resources, and challenges old assumptions. In that moment of breakdown, societies face a stark choice: cling to the fading blueprint of the past, or dare to imagine a new one. The unresolved impact of these ancient upheavals, therefore, is not measured only in what was lost, but profoundly in what was gained in the struggle to rebuild. What new technologies were invented to cope with scarcity? What fairer social contracts were forged in the crucible of shared hardship? What artistic expressions emerged to make sense of a transformed world? The answer is written in the alphabets we still use, the political ideas we still debate, and the resilient, adaptable spirit of communities that learn to bend rather than break. This adds a crucial layer of hope and complexity to our historical understanding, suggesting that within every crisis lies a seed of potential, waiting for the right conditions to sprout. The ruins and stories we have explored are not locked safely in the past. They are a mirror reflecting a challenge we now face on a planetary scale. Our own era is defined by a rapid, human-caused transformation of the atmosphere, a climatic experiment of unprecedented speed and scope. While no historical parallel is perfect, the unresolved struggles of early civilizations offer us a stark and vital form of education. They provide case studies in vulnerability and resilience, written in the language of human experience across millennia. By studying how these societies responded to pressure, we are not just satisfying historical curiosity, we are engaging in a critical act of foresight. The past clearly illustrates the perils of building a society on a narrow foundation. We saw this in the Akkadian empire's over-reliance on a single, vast irrigation system, and in the Greenland Norse's stubborn commitment to a European pastoral lifestyle in a cooling world. Their stories warn us about the dangers of over-specialization and cultural inflexibility. In our globally connected world, similar risks exist. Our food systems often depend on a handful of staple crops grown in concentrated regions. Our energy and economic networks are deeply intertwined. This creates incredible efficiency, but also profound systemic risk, just as it did for the Maya when drought struck their entire region simultaneously. The lesson is not that complexity is bad, but that it must be balanced with redundancy and the capacity for rapid adaptation. Conversely, history also provides models of enduring resilience, often found in societies that cultivated a deep, reciprocal relationship with their environment. Many indigenous cultures, from the ancestral Puebloans with their water harvesting techniques to the diverse subsistence strategies seen across continents, developed knowledge systems built on observation, flexibility, and long-term stewardship. They often operated with a mindset of managing for abundance within ecological limits, rather than maximizing short-term extraction. This represents a fundamentally different approach to resource use, one that prioritized sustainability and distributed risk. Their legacies remind us that resilience is frequently rooted in diversity, both ecological and economic, and in social cohesion that enables collective action during times of crisis. Perhaps the most urgent lesson is that environmental stress rarely acts alone. It finds and exploits pre-existing weaknesses. In the past, droughts and cold snaps amplified social inequality, political instability, and resource competition, pushing strained systems past their breaking point. This pattern holds a powerful warning for our present. A changing climate will not simply be a matter of warmer temperatures or rising seas. It will be a multiplier of every other challenge we face, from economic disparity to political polarization to global health. The fate of the late Bronze Age world shows how interconnected systems can fail together in a cascade. Our modern globalized civilization is the most interconnected in history, which means our potential for shared prosperity is matched by a potential for shared fragility. This makes the study of ancient climate shifts far more than an academic pursuit. It is a practical and profoundly urgent form of preparedness. By understanding how civilizations have weathered or founded upon the shocks of the past, we gain insight into the kinds of choices that lead to renewal rather than ruin. We learn that the most dangerous response is often denial or rigidity, the refusal to change course when the old ways are clearly failing. We see that societies that survived climatic trials were often those that could simplify, decentralize, migrate, or innovate their way into a new equilibrium. They remembered how to adapt. Our challenge is monumental, but it is not without precedent. We are the first generation to see this change coming with scientific clarity, and the last with a window to influence its trajectory with deliberate action. The unresolved impacts of the past are now a conversation with our future. They ask us what kind of ancestors we wish to be. Will we be remembered for clinging to unsustainable systems until they broke, or for harnessing our collective knowledge and ingenuity to navigate this great transition? The stories of dust-covered empires and silent cities are not prophecies. They are choices already made, urging us to make wiser ones. High on the windswept altiplano of the Andes, where the air is thin and the sun intense, the Tiwanaku state built a civilization that seemed to defy the very harshness of its home. For centuries, their capital city, with its monumental Gate of the Sun and precisely fitted stonework, stood as a testament to human ingenuity. Their secret was not conquest, but a profound partnership with water. They transformed the marshy shores of Lake Titicaca, the highest navigable lake in the world, into a masterpiece of agricultural engineering known as raised field agriculture. They dug a grid of canals and piled the excavated soil into long, rectangular planting platforms. This simple-sounding act was revolutionary. The surrounding canals absorbed the fierce daytime heat, releasing it slowly at night to protect crops from frost. They recycled nutrient-rich silt and aquatic plants back onto the fields as fertilizer. This system created lush, productive microclimates in a landscape where conventional farming would have struggled, supporting a dense population and a complex society. Their success was absolute until the lake itself began to change. The story of that change is preserved in the deep, cold mud at the bottom of Lake Titicaca. Sediment cores extracted by scientists reveal a stark climatic chapter. Around the year 1000 of the Common Era, the layers show a dramatic increase in dust and a shift in the types of preserved algae, clear chemical fingerprints of a prolonged and severe drought. The lake level dropped perhaps by many meters over several generations. For the Tiwanaku, this was not merely a dry spell, it was a direct attack on the foundation of their world. Their entire agricultural system was a capillary network extending from the lake's edge. As the shoreline receded, the canals that fed their raised fields would have run dry or become disconnected. The delicate thermal regulation the water provided would have broken down, leaving crops exposed to killing frosts. The nutrient cycle would have collapsed. What began as a hydrological problem became an immediate and catastrophic food crisis. This forces us to consider a difficult social mystery. the authority of Tiwanaku's ruling elite was likely intertwined with their perceived mastery over these life-giving forces. They may have been seen as divine intermediaries responsible for ensuring the fertility of the fields and the abundance of the lake. So what happens when the rituals fail, when the prayers for rain go unanswered for decades? The legitimacy of the entire political and spiritual order would have evaporated as surely as the water from the canals. In the face of widespread hunger, the social contract that bound outlying communities to the ceremonial center in the city would have shattered. The central authority, unable to provide its most basic promise of sustenance, would have found its power draining away. The unresolved impact of this crisis is seen not in a single catastrophic end, but in a purposeful dispersal. The great urban center of Tiwanaku was gradually abandoned, but its people did not vanish. They migrated, carrying their profound agricultural knowledge with them. This diaspora of expertise is thought to have seeded the valleys and slopes across the central Andes. The raised field technology, the understanding of microclimates and water management did not die. It was preserved and adapted by smaller, more resilient communities. This dispersed knowledge pool later became part of the cultural toolkit that enabled the rise of another great civilization, the Inca, who would build their empire on a foundation of sophisticated agricultural terracing and state-managed resource distribution. The cautionary tale of Tiwanaku is one of brilliant optimization meeting a changing rulebook. They had perfected a system for a specific set of environmental conditions, and it worked magnificently. But their success made them exquisitely vulnerable to a single point of failure, the level of Lake Titicaca. When that one variable shifted beyond a tolerable range, their entire adaptation, however advanced, became a trap. It is a powerful reminder that in our relationship with the environment, there is a fragile line between a tailored solution and a dangerous dependency. Their story asks us to consider what phenomenally successful systems we rely on today that might be perfectly designed for a world that is already slipping away. A changing climate does more than just parch fields or flood cities. It can open a door for an even more invisible and relentless enemy. Throughout history, the most devastating blows to civilization have rarely come from a single source. Instead, they arrive in a lethal partnership where environmental stress teams up with biological catastrophe to break a society's back. The mechanism is brutally simple. A shift in temperature or rainfall can rearrange the entire living map. It can expand the comfortable range for mosquitoes carrying malaria or yellow fever. It can drive populations of rodents and the fleas they carry into closer contact with human settlements in search of food and water. Perhaps most critically, a climate-induced famine does not just cause hunger. It systematically degrades the human body's defenses, creating a population-wide vulnerability. When a novel pathogen arrives in such a weakened community, it does not merely spread, it ravages. This deadly synergy transforms a climate event from an environmental crisis into a full-scale demographic disaster. We can see this pattern with terrifying clarity in one of history's most documented pandemics. The plague of Justinian erupted in the port city of Constantinople in the year 541 during the reign of Emperor Justinian. It was a form of bubonic plague, likely carried by rats and their fleas, and it swept across the Mediterranean world in waves, killing perhaps tens of millions. But to understand its catastrophic impact, we must look at the years just before it arrived. This was a period of profound climatic instability. Ice core records point to a series of massive volcanic eruptions around the year 536, events that ejected so much sun-blocking ash into the stratosphere they triggered a sudden global cooling. Contemporary writers from Byzantium to China described a mysterious, persistent dry fog that dimmed the sun for over a year. Summers turned cold, crops failed across continents, and a great famine began. This was the prelude. A population already emaciated and desperate from years of hunger and cold was a tinderbox waiting for a spark. When the plague bacterium Yersinia pestis arrived via trade routes from Asia, it found a world of perfect hosts, their immune systems compromised by malnutrition, living in densely populated, unsanitary conditions where the disease could jump with ease. The climate shock did not create the plague, but it prepared the stage for a tragedy of unimaginable scale. The unresolved impact of this partnership is a compound fracture in the very fabric of society. It is not just the loss of life, staggering as that is. It is the cascading failure of every system that holds a civilization together. When a significant portion of the labor force is lost, fields go untended, accelerating the food crisis. Artisans, administrators, and soldiers perish, crippling the economy, the government, and defense. The sudden, seemingly random nature of the illness can shatter religious faith and social trust, as people struggle to understand a punishment with no apparent cause or pattern. In the aftermath of the Justinian plague, the Eastern Roman Empire, though it survived, was permanently enfeebled. Its dreams of reconquering the lost Western provinces evaporated. Its tax base shrank, and its ability to project power was forever diminished. The pandemic, supercharged by climate stress, helped cement the end of the classical world and shape the more fragmented, localized societies of early medieval Europe. This historical lesson frames climate change as the ultimate threat multiplier. It rarely invents new dangers. Instead, it amplifies existing vulnerabilities and unlocks dormant ones. A warming world today could alter the geographic range of vector-borne diseases, bringing malaria or dengue fever to new, unprepared populations. Changing precipitation patterns can compromise water quality and sanitation, increasing the risk of cholera and other waterborne illnesses. Extreme weather events can displace millions, forcing people into crowded refugee camps where disease can spread rapidly. And just as in the 6th century, any disruption to global food systems weakens overall health on a planetary scale. The past shows us that when the environment becomes unstable, it does not act in isolation. It shakes the complex web of life until something else, often something microscopic and deadly, breaks loose. Our ancestors faced this synergy with little understanding and few defenses. Our challenge is to heed their story, to recognize that safeguarding our future requires fortifying not just our infrastructure against storms, but our global health systems against the biological shocks a changing world may unleash. A parched landscape holds a hidden river. Across the deserts of ancient Persia, communities faced an impossible equation: how to survive in a land where surface water evaporated faster than it could be used. Their answer was not to fight the sun, but to work beneath it. They engineered the Qanat, a gently sloping underground tunnel that tapped into water trapped in the foothills of mountains, guiding it silently for miles through the dry earth to their fields and cities. This was not a simple ditch, but a masterpiece of surveying and communal labor, with vertical access shafts dug along its length for construction and maintenance. The Qanat did not just bring water, it created life in places where none seemed possible, and its success depended entirely on a deep, shared social contract to maintain the system for generations. Far across the world, in the Valley of Mexico, another civilization faced a different water puzzle. The Aztecs built their capital, Tenochtitlan, on an island in a lake. With limited arable land, they invented the chinampa, often called a floating garden. These were not actually floating, but rectangular plots of fertile lakebed built up from layers of mud, vegetation, and reed mats anchored by willow trees at their corners. Chinampas were incredibly productive, yielding multiple harvests each year, and their network of canals provided both irrigation and transportation. This technology transformed a marshy lake into one of the most productive agricultural landscapes of the ancient world, supporting the dense urban population of a mighty empire. Beyond these grand engineering feats, quieter revolutions were happening in countless fields. From the terraced slopes of the Andes and Southeast Asia to the drought-resistant millet and sorghum varieties cultivated across Africa, our ancestors were the world's first plant breeders. Through careful selection over generations, they nurtured crops that could thrive with less water, withstand temperature extremes, or grow in salty soils. This was a slow, collective form of biotechnology, a deep dialogue with the natural world to coax resilience from the very seeds they depended on. These stories of the Kanat, the Chinampa, and the resilient seed are powerful testaments to human ingenuity under pressure. They show a capacity to not just endure a changing climate, but to reimagine the relationship with the land itself. Yet this legacy also contains a caution. Why did some of these brilliant adaptations endure for 1,000 years, while others were eventually abandoned? The Kanat systems required a stable, cooperative society to maintain their intricate tunnels, a social technology as vital as the engineering one. The Chinampas flourished within a specific ecological balance of the lake. When that context changed, whether through social upheaval, environmental shift, or both, the technology alone could not save the system. This is the unresolved heart of ancient innovation. A technology is never just a tool, it is a relationship. Its success depends on being woven into the social fabric, the ecological limits, and the cultural values of the society that created it. It is a solution for a specific world. When that world changes too drastically, the most ingenious machine can become a relic. Our modern world is built upon this same legacy of problem-solving. Drip irrigation echoes the water-conserving principle of the Kanat. Greenhouses and hydroponics share a kinship with the controlled environment of the Chinampa. And our ongoing quest for drought-tolerant crops continues the ancient work of seed selection, now accelerated by science. The lesson from our ancestors is not simply to innovate, but to innovate wisely, to build solutions that are in harmony with their context, and to remember that the most resilient system is one that can itself adapt, change, and sometimes, when necessary, be let go in favor of a new beginning. The classic story of Easter Island reads as a stark parable for our times. A remote Polynesian society, the Rapa Nui, builds magnificent stone statues called moe, but in doing so, cuts down every last tree, triggering ecological collapse, famine, and societal ruin. It is a powerful tale of self-destruction, a warning of what happens when a culture loses sight of its environmental limits. But like many compelling stories, the full truth is more complex, and climate science is now adding critical, challenging layers to this narrative. Pollen cores taken from the island's lake beds and swamps tell a surprising story. They reveal that the island's iconic palm forests were already in a state of decline, likely due to a natural trend toward a drier climate, long before the first Polynesian canoes ever touched its shores. The human settlers did not find a pristine, endless woodland. They arrived on an island whose ecosystem was already under subtle stress. This changes the opening chapter of the story entirely. The deforestation was not the first act of an ecological tragedy, but an interaction between human activity and an environment already shifting on its own. The pressure intensified centuries later with the global onset of the Little Ice Age. For Easter Island, this likely meant cooler temperatures and even less reliable rainfall, a double blow to an agricultural system already balancing on a knife's edge. Growing the staple sweet potato, or kumara, would have become increasingly difficult. The island was not a static paradise that people ruined. It was a dynamic, fragile system that became more fragile still under a changing global climate. So how did the Rapa Nui respond? The classic collapse narrative focuses on the end of moe construction and tales of conflict. Yet newer archaeological evidence paints a picture of remarkable, painful adaptation. As resources grew scarce, the societal energy once poured into erecting colossal statues appears to have been redirected. The old ancestor-focused religion, centered on the moe, gave way to a new spiritual practice, the birdman cult. This was not a random shift. The cult focused on an annual competition to retrieve the first sooty-tern egg from a treacherous offshore islet. The winner's clan gained sacred authority for the year. This ritual was a profound adaptation. It shifted the focus of prestige from stone, which was immovable and required vast communal labor, to a renewable, living resource, the seabird. It was a way to manage competition and distribute status in a world where traditional agriculture could no longer support the old ways. This reframing forces us to ask a difficult, unresolved question. How much of what we call collapse on Easter Island was actually a conscious, if incredibly difficult, societal transformation? The people did not simply vanish when the trees were gone. They changed their politics, their spirituality, and their economy. They simplified, they adapted, they found a new way to be Rapa Nui in a world that could no longer sustain the old one. This is not to dismiss the very real hardship they endured, or the role their actions played. Rats that arrived with the settlers certainly contributed to deforestation by eating palm seeds. The lesson is not that humans bear no responsibility, but that their story unfolds within a larger environmental context that is also changing. The unresolved impact of this narrative is a challenge to our modern perspective. It asks us to move beyond simple morality plays of ecological suicide. Instead, we see a resilient people navigating a series of compounding challenges, both of their own making and from forces far beyond their control. Their story becomes less a blunt warning and more a deeply human study in adaptation under extreme pressure. It encourages a more empathetic view, one that recognizes the impossible choices communities can face when the world they built their lives upon begins, quite literally, to crumble beneath them. The silent testimony of ancient bones tells a story deeper than drought or flood. When the climate turned against a civilization, the resulting hardship was not a great equalizer. It was a force that exposed and intensified every existing crack in the social foundation. In the stratified societies of the ancient world, from Mesopotamia to the Andes, the first and most devastating blows of a changing climate consistently fell upon those with the least power to withstand them. While rulers in their fortified palaces might watch the horizon with concern, the farmers in distant villages were already tasting the dust of failing fields. Archaeological evidence from sites across the globe reveals this stark disparity. Studies of skeletal remains from different social strata show clear patterns. In common burial grounds, bones from the period of a known drought or cooling event often exhibit markers of chronic malnutrition and physiological stress, such as lines of arrested growth in teeth and bones, indicating periods of severe illness or hunger during childhood. These signs are far less frequent or entirely absent in the remains of elites found in richer tombs associated with palace complexes. The message in the marrow is unambiguous. The elite had a buffer, a stockpile of grain and resources that could see them through several lean years, while the common population lived on the razor's edge of survival, where one failed harvest meant immediate catastrophe. This historical reality forces an uncomfortable but vital ethical question. In the face of a shared environmental threat, do human societies have a tendency to protect the powerful and sacrifice the vulnerable? The pattern suggests that often the answer is yes. The very structures designed to manage surplus in times of plenty, the granaries and storehouses, frequently fell under the control of kings, priests, and nobles. When scarcity arrived, the decision of who would eat and who would not was rarely a democratic one. The social contract, the implicit agreement between the rulers and the ruled, was based on the elite providing security and prosperity. A prolonged climate crisis shattered that promise, but it did not shatter the mechanisms of control. Instead, it could turn those mechanisms into instruments of survival for the few at the expense of the many. This inequality in suffering did not go unchallenged. The unresolved social impact of these ancient climate shocks is written in waves of unrest, revolution, and the dramatic renegotiation of power. When a population has nothing left to lose, the legitimacy of a ruling class that hoards the last sacks of grain evaporates. Historians note that periods of intense climatic stress are frequently followed by evidence of internal conflict, the burning of elite residences, or the abrupt abandonment of ceremonial centers that symbolized the old order. The collapse of the Akkadian Empire or the fragmentation of the Maya Classic period were not just ecological events, they were profound social upheavals. The climate disaster acted as a magnifier, taking pre-existing tensions over land, labor, and tribute and amplifying them into existential conflicts. In this light, a civilization's unraveling was not merely a failure to adapt to the environment, but a failure to distribute the burdens of that adaptation justly. The communities that demonstrated greater resilience were often those with more equitable social structures or strong communal bonds that emphasized mutual aid. The ethical dimension of ancient climate change is therefore not a sidebar to the historical record. It is central to understanding the outcome. It reveals that a society's vulnerability is not just measured by its water storage capacity or crop diversity, but by the strength of its social fabric and the fairness of its resource distribution. When the sky withholds its rain, it does not see kings or peasants, but the granary doors built by human hands most certainly do. This ancient pattern of disproportionate suffering holds a critical mirror to our modern globalized world, where the consequences of a changing climate are already falling hardest on those who contributed least to the problem, challenging us to ask if we will repeat the old, tragic formula or finally learn to write a new one. For all the ice cores we have drilled and the tree rings we have counted, vast silences still echo through this history. We have assembled a compelling narrative from fragments, but we must also acknowledge the profound gaps that remain in our understanding. Our view of these ancient climate society interactions is like a mosaic where many of the original tiles are lost forever, leaving us to guess at the full picture from the pieces that survive. The first great silence is the absence of writing. Countless societies, from the builders of the Indus Valley cities to the architects of Cahokia, left behind no deciphered chronicles of their own experience. We see the physical evidence of their struggle, the silt layers and the abandoned streets, but we cannot hear their voices explaining why they left, what they feared, or what they hoped to find. We are left interpreting their actions without their intentions, a fundamentally incomplete conversation across time. Even where we have proxy data, it is often open to interpretation. Take the monumental 4.2 Kiloyear event. We have strong evidence of a global aridification that reshaped civilizations from Egypt to China. But the precise trigger, the exact sequence of atmospheric and oceanic changes that flipped the switch, remains a subject of intense scientific debate. Was it a sudden shift in monsoon patterns, a change in North Atlantic currents, or a complex cascade of feedback loops? The climate models give us clues, but the definitive mechanism is still just out of reach. Similarly, the story of the Indus Valley dispersal is clear in its outcome but opaque in its process. We see the migration eastward in the archaeological record, but the social mechanics of that decision are a mystery. Was it a coordinated, planned exodus led by elders and priests, or was it a slower, more desperate trickle of families making individual choices to survive? Did they see themselves as abandoning a failed project or simply moving to a better home? The silent streets of Mohenjo-Daro cannot tell us. And then there are the sea peoples, the enigmatic marauders of the late Bronze Age collapse. Egyptian reliefs name them and show their defeat, but their origins and motivations are one of history's great ghost stories. Were they a coalition of climate refugees from collapsing Mycenaean or Anatolian kingdoms, as many now suspect? Or were they something else entirely, a symptom of the collapse rather than its cause? Without a single surviving text from their perspective, they remain silhouettes against a burning horizon, symbols of the chaos of that age rather than understood historical actors. These gaps, however, are not failures of our scholarship. They are invitations. They mark the frontiers of future discovery. Every unanswered question is a beacon for the next generation of researchers. New technologies are constantly refining our view. Genetic analysis of ancient human remains is now tracing migration routes with astonishing precision, showing us the movement of people in ways potsherds alone never could. LiDAR scans are revealing lost cities beneath jungle canopies, rewriting our maps of ancient societies. Higher resolution climate models are helping us pinpoint the local impacts of global events. The puzzle is far from complete. This is the vital, humbling lesson. History is not a solved case file to be shelved and forgotten. It is an ongoing investigation, a living dialogue between our present curiosity and the silent evidence of the past. The very act of grappling with these mysteries, of trying to connect the climatic dots to the human stories, is what keeps this history alive and urgently relevant. It pushes us to ask better, more nuanced questions, not just about dust and tree rings, but about the human condition itself. How do communities make impossible choices? What does resilience truly look like? And what stories will our own civilization leave in the layers for some future people to ponder? From the dust of Akkad to the silent stones of Angkor, a consistent rhythm begins to emerge from the noise of history. These stories, separated by oceans and millennia, are not random tragedies. They are variations on a theme, a recurring melody of pressure and response that reveals profound patterns in how civilizations meet a changing sky. The first and perhaps most powerful pattern is the fragility of the centralized state. Again and again, we saw empires that concentrated power, resources, and decision-making in a single, magnificent core. The Akkadians built a vast, irrigated breadbasket. The Maya focused immense labor on monumental reservoirs. The Khmer engineered a hydraulic machine of staggering scale. These were achievements of breathtaking ambition, but they created a profound vulnerability. When the climate shock hit, a drought that spanned the entire region, a monsoon that failed for a generation, there was no backup plan, no other fertile province to call upon. The very efficiency that made them strong became a single point of catastrophic failure. A centralized system is brilliant at distributing abundance, but it often struggles terribly with scarcity because the crisis arrives everywhere at once, and the distant capital cannot possibly understand or address every local breakdown. The second pattern is the peril of the narrow foundation. This is the danger of building your entire world upon one resource, one crop, or one source of water. The Greenland Norse clung to a European pastoral identity, refusing to adopt the seal hunting technologies that thrived around them. The Moche, masters of desert canal irrigation, were helpless against the climatic whiplash of floods and droughts that destroyed their intricate systems. Their societies were exquisitely optimized for a specific, stable set of conditions. When those conditions shifted beyond the design limits of their adaptation, they had no alternative pathway to survival. Their brilliance became a trap. In contrast, the societies that demonstrated greater resilience often cultivated diversity in their food sources, their economic activities, and their connections to the wider world. This leads directly to the third pattern, the indispensable role of social fabric and flexible governance. A climate shift is not just an environmental test, it is a stress test for human relationships. When hardship arrives, does the society pull together or pull apart? The evidence suggests that rigid hierarchies, where a distant elite is seen as divinely responsible for prosperity, are the first to fracture when that prosperity fails. The legitimacy of kings and priests evaporated with the rains. Societies with stronger communal bonds, more equitable resource sharing, or governance structures that allowed for local adaptation, like the dispersed communities that succeeded the Indus Valley civilization or the ancestral Puebloans, were better equipped to make collective, difficult decisions. They could choose to migrate, to simplify, or to transform without their entire world dissolving into chaos. And weaving through all these patterns is the most common antagonist of all, drought. While volcanic winters and floods delivered sudden, dramatic blows, it was the slow, suffocating pressure of aridity, the years when the rains did not come, the rivers shrank, and the dust blew, that most consistently wore down the pillars of civilization. Drought is an insidious enemy. It works slowly, allowing for denial until it is too late. It attacks the very basis of settled life, the agricultural surplus, and in doing so, it amplifies every other social and political tension. Yet for all these common threads of vulnerability, the most important pattern of all is the stunning diversity of human response. The climate provided the shock, but the people wrote the ending. We witnessed the spectrum of possibility. There was collapse as seen in the abrupt fragmentation of the late Bronze Age world. There was transformation, as with the Maya who shifted their cultural and political center to new lands. There was strategic dispersal as practiced by the people of Cahokia and the Indus Valley. And there was creative rebirth where the fall of old orders, like the Roman Empire, made space for new political ideas and technologies to emerge. This synthesis reveals the core truth of our journey. The fate of a civilization facing climatic upheaval was never preordained by the weather alone. It was the product of a conversation, a tense, urgent dialogue between the pressure from a changing environment and the specific character of the society it pressed upon. The environment posed the question, often brutally, but the answer was always human. It was found in the choices of leaders and communities, in the flexibility of their institutions, in the strength of their shared identity, and in their willingness to let go of what was no longer working. The past does not offer us a single, simple prophecy. Instead, it presents a gallery of possibilities, a map of paths taken and not taken, reminding us that within the great paleo-storms of history, human agency was always the most powerful and unpredictable force of all. Our exploration through the veils of time reveals a fundamental truth: human history and climate history are inextricably braided together. These sudden shifts of the past were not mere backdrops, but active characters in the drama of civilization. They were the ultimate exam, testing the ingenuity, resilience, and sometimes the tragic limits of our ancestors. We have seen how a changing sky could topple empires, silence great cities, and compel entire populations to walk away from everything they had built. Yet the impacts of these events remain profoundly unresolved, and that is the most important part of their story. Their echoes are not locked in the past, they are still with us today. They resonate in the foundational myths we tell about great floods and long winters, stories born from real trauma that shaped how cultures saw their place in the world. They are written in our very genetic dispersal, the map of human migration, often tracing paths away from drought or toward new sources of water. They linger in the silent, poignant landscapes where ruins stand not as monuments to failure, but as waypoints on humanity's long and adaptive journey. As we now stand at our own unprecedented climatic crossroads, facing a change of our own making, these ancient narratives cease to be mere history. They transform into something far more vital, repositories of hard-won wisdom. They are case studies in human behavior under extreme pressure. They teach us with stark clarity about the perils of rigidity, of building societies on a single, fragile foundation. They show us the incredible strength found in community cohesion, in diverse and flexible systems, and in the courage to adapt before it is too late. The lesson is not that civilizations are doomed to fall, but that their fate hinges on the choices they make when the old ways stop working. Let this knowledge, drawn from the dust of millennia, be a catalyst for thoughtful and deliberate action in our own time, not a source of fear. We are the first generation to see the change coming with scientific clarity, and we carry the collective memory of all those who came before us, who faced the changing sky with the tools they had. Their stories are now part of our toolkit. If you found this journey into our planet's deep past compelling, subscribe for more explorations of history's greatest mysteries. And we would love to hear your perspective. Which ancient civilization's climate story resonates most with you in our modern world? Share your thoughts in the comments below.